Awesome. Another one assignment where every single person completed it. This is really great. I think that extending the deadline is really helping with this. So there are 2 questions on this assignment that were a little rough. So we're going to look at this first one with the graph, and then we're going to look at this related rates type problem. And here we've got the graph of f prime, the derivative of f, and we have an initial condition of 0. And it asks which of these must be true, and it's asking about f, the function, not f prime. So what I found easiest to do is just sketch in some things. So we know it goes through the origin. That's what this initial condition here means. And the slope is positive at this point. And so so we know it's going up. And then it's going to flatten out at 1 because that's where it's 0. And then our slope is still positive here. So it's going to keep going up until it flattens out again at 2. Because that's 0. And that's when it starts going down again. Whoop. Doesn't need to be doing that. It can go down pretty much like that. Okay. So the question is then, which of these must be true? So we're looking at f of 0 here, f of 1, f of 2, and f of 3. So the question is, which ones must be true? Well, I'm going to use a process of elimination. Number 1 says 0 is greater than f of 0 is greater than f of 1. Well, the slope is positive here, so we know that one can't be, which helps us eliminate A, which is nice to see no one picked, but it also helps us eliminate D. So now we're looking at 2 and 3. For number 2, we're looking at f of 2 is greater than f of 1. Right, this one's true because in between 1 and 2, the slope is still positive, so we're still going up. So that one could be true. Well, that one has to be true, not could be, has to be. So we know that C only, 3 only isn't right. So now we're stuck between, is it 2 or is it 2 and 3? So here is f of 1 is greater than f of 3. And this is where it's a little bit tricky because here, this could be higher or lower depending on exactly what the scale is on here. But as you can see here, I've drawn a pretty decent picture, and this is going up pretty steeply here compared to this. So it's unlikely that this is going to be able to make it all the way down below f of 1. It's possible, but here's the nice thing, the way it's worded, which ones must be true? And just because it says it's possible doesn't mean it has to be true. So we can eliminate that one as well, leaving us with just 2 as being the only one that must be true. All right, let's look at this problem here. The sides and diagonal of a rectangle above are increasing with time. At the instant when x equals 4 and y equals 3, and dx dt is equal to dz dt, and dy is equal to a constant times dz dt, what is the value of in that instant? So I'm going to fill in some of the information here. We know that this is 3. We know that this is 4. We know that this is a nice Pythagorean theorem problem, so hopefully all of you would be able to say, oh, it's a 3, 4, 5 triangle. And we know that x prime is equal to z prime. Here, we know that those two are equal. And then the question is, what is k? So I'm going to use the Pythagorean theorem, which x squared plus y squared equals z squared. When I take the derivative in terms of t, I ended up with 2x x prime plus 2y y prime equals 2z z prime. We know that x prime is equal to z prime. We know that y prime is equal to k z prime. And now we can solve. A lot of these terms have really common things. So I'm just going to eliminate a 2 from each, and I'm going to eliminate a z prime from each. And we're left with the equation x plus y times k is equal to z, which at this instance is 3 plus, not 3, x is equal to 4 plus 3k equals 5. 3k is then equal to 1, and k is equal to 1/3. So, hopefully that helped on those two problems where the most people were stuck, but honestly, this is a pretty well done assignment.